Hello everyone, welcome to the channel. In this video, we are going to look at a strategy for solving trigonometric integrals involving powers of tangent and secant. There's going to be two little tips here. So the first one is going to be if secant is an even power. So if secant of x is an even power, so that means n is equal to 2k, then what we're going to do is we're going to save a factor of secant and use the identity of secant squared. We're going to save a factor of secant squared, and we're going to use that factor with an identity to change it from secant squared of x is equal to 1 plus tangent squared of x. And then we're going to leave the remaining terms in tangent squared, or in tangent, sorry. So you'll see why we're going to do that. So let's go ahead and write this out in the integral. We're going to change the power of secant to the n to be secant equals, or secant to the 2k. So this is going to be the integral of tangent to the m power of x times secant of x to the 2k power dx. But this is the same as tangent to the m power of x times secant squared of x to the k power dx. And here we're going to pull out a factor of secant squared. So tangent to the m power of x times secant squared of x. Now we pull this factor out, we're going to call this k minus 1 because we're taking a factor out of here. We're going to write secant squared of x dx. And then we're going to convert this secant squared inside of the brackets to a 1 plus tangent squared. So we have the integral of tangent to the m power times 1 plus tangent squared of x, all to the k minus 1 power, times secant squared of x dx. Now, we're going to make a u substitution here, and we're going to let u equals tangent of x, then our du is equal to secant squared of x dx, and right away we have secant squared x dx right here. And then the remaining terms are all in tangent, which we can use with this u substitution. Then we are going to do the integral with our u substitution in place. The integral of u to the m power times 1 plus u squared to the k minus 1 du. Now all that's left to do is, so in an actual problem, this m and this k are going to be numbers, right? So all you're going to do here is you're going to FOIL out this binomial term in the middle, and then distribute that u to the m term, whatever the power is, into whatever you FOIL it out to be. And then you're just going to do a regular integral. And then once you're done, you're going to back sub this u equals tangent x back into your result, and then you'll be done with this part, okay? So the next one is going to be if the power of tangent is odd. So if the power of tangent of x is odd, so that means it's of the form m equals 2k plus 1, right? Then what we're going to do is we're going to save a factor we want to create a factor of secant x tangent x, or tangent x secant x, doesn't matter which way. And we're going to do this by pulling out a factor from the other terms, and with that we're going to make our u sub. So let's go ahead and get into that. Sorry. So that's going to be the integral. So I'm going to rewrite this integral, but I'm going to let m equal 2k plus 1. So then we have tangent of x to the 2k plus 1. And then we have secant of x to the n dx. Now, I want so when we're adding exponents, that means we're multiplying the bases. Now, what I want is a secant x tangent x factor, right? It doesn't have to be in that order. That's what I want attached to my dx when I make the u sub. So in order to get that, I need to pull one factor out of here, and then I'm just going to pull one factor out of here. So it's going to be the exponent minus 1 for each of them. And on this tangent, the exponent is just going to drop down to 2k. And for secant, the exponent is going to drop down to n minus 1. So again, if you're working a problem, then these will be numbers, and it's not going to be variables. So it'll be a little bit easier for you to see. So tangent of x to the 2k times, sorry, my stylus pencil is messing up, times secant of x to the n minus 1. So our factor of tangent times tangent of x times our factor of secant times secant of x dx. So next I'm going to say well, first of all, before we get to our u sub, let's go ahead and move this this squared in here, and we'll leave the k on the outside of the bracket. And then, well, let me just write it right here. So this is the same as tangent squared of x all to the k, this term, right? So I'm going to replace that with secant squared x minus 1. So this is going to turn into secant squared x minus 1 to the k power times secant of x to the n minus 1 tangent x secant x dx. Now I'm ready to make my u sub. I'm going to let u equal secant x, and then du is going to be equal to tangent x secant x, or secant x tangent x, either way. Tangent x secant x dx. And then we have that term here. And then everything else is in terms of secant. And we're ready to do our substitution. So then we have the integral of u squared minus 1 to the k power times, well, I don't need the bracket here, times u to the n minus 1 du. Now, again, you're going to have numbers, so just figure out what your exponents are, and then you can FOIL out that binomial first, or you can multiply that external factor of u in if you're comfortable doing that. But once you FOIL that out, you are going to be left with a series of u to a power in your integral, and then you just do that integral, which is going to be, you're going to find the antiderivatives for power rule, and then you're going to back sub your u equals secant x into your result, and then you'll have your answer there. So if you're not sure, so one thing I'll point out real quickly before I wrap this up if you're not sure where to get these identities from, so this 1 plus tangent squared or this secant squared x minus 1, a trick you can do is you can start with cosine squared of x plus sine squared of x is equal to 1. Okay? Now, if I multiply this whole thing, all right, by 1 over cosine squared, so let me write it like this. So 1 over cosine squared of x, 1 over cosine squared of x, then your result is going to be 1 plus tangent squared of x, because this term is sine squared x over cosine squared x, which is just tangent squared of x, right? Equals 1 over cosine squared of x, and 1 over cosine is secant, so then 1 over cosine squared is going to be secant squared. Okay, and then from here you can manipulate this to solve for tangent x. You just subtract 1 from each side, and then there you have it. Separately, you could do the same thing, but with sine. So you multiply everything by 1 over sine squared of x, 1 over sine squared of x over here. And then this first term is not tangent, but this is going to be cotangent squared. So you're left with a cotangent squared of x plus 1 is equal to 1 over sine squared of x, but 1 over sine is just cosecant, right? So that means this 1 over sine squared of x is going to be cosecant squared of x. And then again, if you want just cotangent, you just subtract 1 from both sides, and you're left with cosecant squared minus 1. So all you need to do is start from this right here, this identity that pretty much all of you are going to know if you're doing integrals like this, and then you just multiply it by either 1 over cosine squared or 1 over sine squared, and it'll drop out these identities that are going to be helpful when you're making your substitutions in these problems. So I hope that this video has been helpful for you. I hope that it's helped you get a little bit more clarity on how to get started on these types of integrals, and also how to see them through, as well as how to derive these identities in case you don't want to keep them locked in your brain all the time. So if you have any comments, questions, or concerns, leave them in the comments. If you would like to make a request for content for a video, just send me an email at request@athan.com, which is in the description, and I will get that out as soon as possible. Thank you. Have a good day.